Okay, today's date 1/11/18. Common Core Standard is really we're going to be solving. We're going to be solving radical equations and inequalities. So again, radical is just a fancy math word for square roots or cube roots, okay? Square roots or even cube roots or whatever roots, just an nth root of something, okay? That's just a fancy word. So the word radical means square root, nth root, or whatever it happens to be, okay? They're called radicals because they're irrational numbers, right? They're like pi, they go on forever. So let's take a look at example 1. So example 1, we're just going to solve. This shouldn't be too difficult for a lot of you. You know, just go ahead. The 2's on the outside. Divide by 2, right? That makes sense. You cannot distribute. You can't bring that inside. So I get the square root of x plus 1 equals 7. The way you undo a square root is by squaring. So I'm going to square both sides because that will get rid of the square root. So I'll be left with a x plus 1 equals 49. And minus 1, x equals 48. I think that answer is okay, but we can go back and check it. The easiest way to check is you plug it back in, right? Just plug it back in. So if I were to take my 48, and if I wanted to check it, do a real quick check, right? If I plug it back in, you know, 48 plus 1 is 49. That's okay, right? Everybody agree with that? Square root of 49 is 7. 7 times 2 is 14, okay? So it's an easy check. It works, right? No problems there, okay? Okay, number 2. So the nice thing about cube roots is they can be negatives. So almost always a cube root will work, okay? Cube roots can be negative. We'll still look at it, but negative answers are okay. So let's put up here negative answers are okay for a cube root. Okay, negative answers are okay. We looked at the graphs of cube roots yesterday, and they go positive and negative, right? So let's just graph it, or let's solve it like we always do. So divide by 5, right? We'll have the cube root of a 4x plus 3 equals 3, right? It's just solving, so we're going to continue to undo it. So we undo it to get rid of the cube root, we'll cube both sides, okay, because that will eliminate or dissolve or cancel out the cube root. So then we just have a 4x plus 3 equals 27. 3 times 3 is 9 times 3 is 27. Minus 3. I've got a 4x equals a 24. Divide by 4 and x is 6. That answer is fine too. Okay, we can have a negative answer. We can have any answer we want, but x equals 6 is great. Okay, that was pretty simple. You guys agree? So we're just solving. The only difference is that sometimes we'll have to cube, sometimes we'll have to square to get rid of cube roots or square roots. Okay. All right. Now example 3 is a little bit different, and that is we get square roots on both sides. Okay, and we get a 5 that's not in the square root, but I still am going to square both sides. Now listen carefully. When I square both sides, I've got to be careful of the 5. I'm going to have to square the 5 also. So if I square both sides to eliminate the square root, I'm going to have to be careful of the 5 also. Okay, if I square both sides, the 35x is inside, so the square root and the square kind of cancel each other out. So I get a 35x. But over here, the 5 is not. So the 5 needs to get squared. The 5 gets squared, becomes a 25. And then the square with the square root cancels that out, and I just get an x plus 2. Okay, so I squared the 5, got a 25, squared the square root, and got an x plus 2. Okay, now I'm just going to solve, right? You know, distribute that times that, and that times that. I get a 25x plus 50, right? So I got a 35x equals a 25x plus 50 minus 25x minus 25x. I get a 10x equals 50, right? Divide by 10 and x equals 5. So I'm gonna, if with the square root, I'm gonna do a real quick check. I think the checks are always worthwhile. So I plug a 5 up into x and up in for x. I think I'm okay, because if I go 35 times 5, positive number, right? Positive number. And then obviously 5 plus 2 is 7, positive number. You don't have to worry about it. So this answer is good. Don't have to worry about it yet, okay? All right. Example 4. Well, it's very similar to what we just did. Very similar, right? We square both sides to get rid of the square root, and square this other side, square the right-hand side to get rid of the square root. We got to remember the 3 is going to get squared. Okay, the 3 is going to get squared also. So the square cancels the square root, and I'm left with an 8x plus 6, because the square root and square root cancel each other out, right? On the right-hand side, I got to square the 3. So it gets a 9, and then square the square root is x, okay? How am I doing? So far, so good? Okay, then I'm going to go minus 8x, minus 8x. I've got 6 equals x. Is 6 going to work? I think 6 will work. Because if I check it, I put 6 in here, I get the square root of 6, kind of an ugly number, but it'll work. 3 times square root of 6, put the 6 in here. 8 times 6 plus 6, okay? So I believe that answer will work. What we're really worried about more than anything are negatives, right? It's the negatives. Okay, example 5. Here comes the first really fun one. All the rest are kind of boring. Those last 4 were kind of boring, but here comes a fun one. All right, let's solve it. Let's square both sides. Square this side, okay? Now, if I square the square root, it cancels out much just with x plus 18, okay? Equals. This is a, well, it is not, and I'm going to put up here and erase it. I had this discussion with Landon yesterday. My goodness, Landon. It is not x squared plus 4. It is not x squared minus 4. It is not. It's a FOIL problem. It's a FOIL problem. Because, and I'll do it on the side, it turns out that what we're really looking at is, over here on the side, screwdriver, we want to do an x plus 2, I'm sorry, an x minus 2 times another x minus 2. It's a FOIL problem, isn't it? You guys agree with that? X squared minus 2x minus another 2x plus 4, right? So what it really is an x squared minus 4x plus 4. Okay? All right, now, Leora, I got an x squared. So now I can have 2 answers, right? So originally when I said we couldn't have 2 answers, in this case we're going to have 2 answers because we wound up with an x squared, okay? So we're going to use that f word again. We're going to need to factor. So I'll bring over my x, go minus x, on minus 18, because I want to bring everything over to factor it, right? So I'm going to have 0 equals x squared minus 5x minus 14, right? This will factor x and x, right? Negative 7, positive 2, right? So far, so good? So x is really going to equal 7, and x is going to equal negative 2. But the negative 2 is making me nervous, because I think we talked about the fact that we're not supposed to have a negative inside the square root. So the negative 2, I'm going to check that negative 2. The 7, I think, is going to work. In fact, if I check the 7 real quick, put the 7 here, I get 7 plus 18 is 25, no problem. If I put the 7 here, I get 7 minus 2 is 5, no problem. That works. But the negative 2 is going to be a problem. If you put the negative 2 up here, you get negative 2 minus 2 is negative 4. You can't equal the negative 2. So we're going to throw out the negative 2, all right? Won't work, because you can't have square roots equal to negative numbers, okay? All right, example 6. Pretty darn similar, so let's try and do 6 also, okay? Pretty darn similar. So, first step is to get rid of the square root, right? So I'm going to Square both sides. Square both sides, right? And so the square root and the square cancel each other out, and I'm left with just a 2x plus 14 equals, this is going to be an x plus 3, x plus 3, right? Which is an x squared plus a 6x plus a 9. I mean, you guys, you can FOIL in your head. Can you FOIL in your head? You're smart enough to do that, right? It's like backwards factoring, right? Okay, let's see what we got here. So now I've got a 2x plus 14 equals that. And again, that's that darn F word again. We're going to factor, right? So I'm going to bring everything over. I'm going to go minus 2x, minus 2x. I'm going to go minus 14, minus 14. 0 equals x squared plus 4x minus 5, right? Okay. Factor minus 1 minus 5. No, I'm minus. I want to go positive. Minus 1 positive 5. There we go. I got it. Okay. So then x is going to equal positive 1, or x is going to equal negative 5. And again, that negative 5 bothers me. Thinking I can't be right. And sure enough, if I check the original problem, if I put negative 5 right here, I get negative 5 plus 3 is negative 2. Sometimes negatives can work. For example, if I'd gotten an answer of negative 1, it would have worked. Think about this. Negative 1 would have worked, right? Sometimes negatives can work, but in this case, negative 5 won't, because you end up with a negative. It equals a negative. So throw that one out. Okay. Thumbs up so far? So it's really not hard to solve. You guys are good at solving equations. The hard part is making sure we don't put a negative in there, okay? Okay, turn the page. All right. Example 7. So a couple of days ago we talked about rational exponents. And to the 1/5 power really means the 5th root of 3x plus 5. And no, Leora, you do not have to do this step, okay? Because you take it to the 5th power anyway, right? Okay. So I'm going to take it to the 5th power because we want to undo the 5th root, right? Or you could have taken it to the 5th power right off the bat because it would undo the 1/5, right? You know me. I just show every step because I'm annoying. Okay, the 5th root and to the 5th power cancels each other out. I'm left with 3x plus 5 equals 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32, right? Minus 5, what's that? 8, 17, 27, 3x equals 27, divide by 3, x equals 9. And it's a 5th root. If it's an odd root, it can be negative. If it's an odd root, your answers can be negative, because we know negative, 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 negative is still a negative, so you're okay. All right, example 8. Well, 1/2 really is a square root power, right? You guys agree with that? Or an easier way to say, okay, I'm going to try and skip a step here, is we could just take it to the 2nd power. Because the 2nd power and the 1/2 power would make it to the 1 power. See how that would cancel? So I'm just going to square this side also. Okay, I could have written it as a square root of x plus 12, but gosh, same thing, right? Okay, so then, what am I left with? An x squared is equal to an x plus 12, right? I'm going to need to factor, so I'm going to bring the x this way and the 12 this way, because I like to factor with a positive x squared term. It's easier to factor with. So I'm going to have an x squared minus a 1x minus a 12 equals 0, okay? Because I'm going to subtract my 1x, subtract my 12. How am I doing? Okay. Factor, x minus 4, x plus 3, right? Equals 0. My answers are x equals 4 and x equals negative 3, but maybe not negative 3. Maybe not negative 3 because if I plug the negative 3 in for here into the x, it's going to equal a negative. Can't equal a negative, so we throw that one away, okay? So far, so good. Thumbs up, okay? Now, last but not least is an inequality, okay? So with an inequality, you're going to have a range. You're going to have a range of answers, okay? There's a bunch of answers that will make this less than 4. Bunch of answers, okay? So for instance, 1/2 would work, okay? 1/2 would work. Think about this. I got 2 times 1/2 is 1. No, 1/2 won't work. You might even need negative answers. You might need negative answers. Think about -1, okay? I want you to just visualize. I'm going to show you, okay? Are you watching? Don't fall asleep yet. If x were -1, -1 could work. If x were -1, 2 times -1 is -2, 4. Okay, that'll work. That'll be less than 4, right? 0 will work, right? So there's more than one answer. 0 will work, right? So some negative answers, so there's a range of answers that work. But what can't work are answers that are going to make this value 0, okay? So since there's a range of values, so this is where it gets a little tricky. The first thing we have to do is this. We got to make sure, okay, so there's a range of answers, okay? Okay, there's a spread. There's certain numbers that work and certain numbers won't. So the first thing I do is this. I'm going to take my 2x plus 4. That's what's inside the square. Now, I hope I can explain this. So you pay attention, right? Okay, what's inside of here must be greater than 0 or equal to. It's can't be negative. What's inside of here cannot be negative. So I'm going to take what's here and say greater than or equal to 0. I'm going to make sure that this is, first of all, just what's inside has to be greater than or equal to 0. Okay, because if this is negative, we're in trouble. So I said there's a range with inequalities. You've got to have its lowest point, where the lowest it can be, and that's to make sure it's never negative, and then we'll solve it like we normally solve it, okay? So I'm going to solve this. 2x is greater than or equal to -4. X is greater than or equal to -2, okay? So that's the low end of it. So if I go back, if I plug in -2, okay, think about this. 2 times -2 is -4. -4 plus 4 is 0. Square root of 0 is 0. Is 0 less than 4? Yes. I'll say it again. Watch. So at the very low ends, if x were -2, plug it in. 2 times -2 is -4, right? -4 plus 4 is 0, right? Square root of 0 is 0. Is 0 less than or equal to 4? Yes. So how about -2? Or how about -1? If I put -1 in, we've got 2 times -1 is -2 plus 4 is 2. Is the square root of 2 less than 4? Yes. So that works also in all the decimals and fractions in between. Now there's a high end where it has to be less than or equal to 4. So the second part of this range, so there's two parts. We got first part, I'm going to circle that, and our second part of our range is the high end where we just solve it, okay? Take our square root of 2x plus 4 less than or equal to 4, and we're just going to solve it like we solve all of them, okay? So we're going to square both sides. Square both sides. We'll have a 2x plus 4 is less than or equal to 16. Okay. Minus 4 minus 4, we'll have a 2x is less than or equal to 12. Divided by 2, x is less than or equal to 6. So here's our range. Any numbers in between -2 and 6 will work. Any numbers between -2 and 6 will work and make that a true statement, okay? Any numbers outside of that range won't work. Either it'll make it negative or it'll make it bigger than 4, okay? So your answer for this has to be negative. All my answers bigger than -2 or less than or equal to 6. In set notation, that would be -2 is less than or equal to x, which is less than or equal to 6. In interval notation, remember interval notation, -2 comma 6, okay? All right, here we go. We've got oodles of time to get this done. Page 632, 3 to 23, odd, 79 to 81, okay?